Graphing logarithmic functions, we're going to begin by filling out the table using the function f of x equals 2 to the x power. Once we do that, then we're going to reverse the coordinates and we're going to use that to enter the values into the table. So we look very carefully at each table. Notice the values are just reversed, and then we're going to graph both of these plots of ordered pairs on the graph below. Notice that the original is in black, including its asymptote. Notice that the inverse is in green, including its vertical asymptote. And notice that there is this line between the two functions. Please describe in your own words the relationship between the two graphs and include the significance of the pink dotted line. Be ready to share your response tomorrow in class. This blank here, exponents and logarithmic functions are inverses of one another. So the way that you would write y equals 2 to the x as a logarithmic function is log base 2 of x. Likewise, if the function was y equals 3 to the x power, its inverse is log base 3 of x. We're going to use this understanding to help us solve the next several problems. So when you're asked to graph a logarithmic function, and you're not allowed to use a calculator to do it, you've got to be able first to graph its exponential function. So we start by switching it into exponential form, and that's going to be 3 to the x power. We use the values from this table to create the original, which is f of x equals log base 3 of x. And then we can graph the logarithmic function. In example number 1, I will use two tables and I will graph both graphs. In the remaining examples, I will only use one, and that's the logarithmic table and the logarithmic graph. So I'm going to do -2, -1, 0, 1, and 2. That's 1 over 9, 1 over 3, 1, 3, and 9. Switch your x and y values. And fill in your inverse table. The original function looks something like this. And your inverse table, or your inverse graph, looks like this. The domain and range for your original, remember, is all real numbers, and 0 is less than y. The domain and range of its inverse is simply switched. So 0 is less than x, and the range is all real numbers. In question number 2, we'll be using we'll be using f of x equals 1/3 to the x power. Notice that that's going to be decay as we look at it. That's why your logarithmic function is going to look so strange when we put it into the equation. So we'll use the numbers -2, -1, 0, 1, and 2. Remember, these are our x values for our exponential function. They are our y values for our logarithmic function. If you're having a hard time seeing this, then please put in a second table and fill out the table before making the switch. Domain of this is still, because there are no transformations left and right, greater than 0, and all real numbers. Question number 3, we'll be using f of x equals 6 to the x power to do our graphing. We're still going to use those familiar critical values of -2, -1, 0, 1, and 2 to place into the exponent. Once we do that, we'll find our corresponding y values, which in the inverse are our corresponding x values. Again, if you're having difficulty seeing this in the single table, draw your second table off to the side, put these values in originally as x and y's, then switch their order, and you'll see it. Logarithmic function here looks like this. Kind of like that. It doesn't cross the x-axis. Let's try again. There we go. Sorry, it didn't cross the y-axis. It does cross the x-axis right there. Alright, your domain is going to be x is greater than 0, and your range is all real numbers. Alright, the general form of a logarithmic function hasn't changed. Okay, your multiplier is still a. A is your stretch and compress vertically. If a is negative, you will have a reflection. Left and right for your h is your translation in the opposite direction of what you think, and k is your vertical translation in the same direction you would think, k units. All right, we're going to continue on by looking at the transformations of parent functions, and we're going to look at it from a slightly different point of view. Now what you're going to do is you're going to have to read through the word problem and figure out which equation to write based on what you see in each part. So you notice there's 3 parts of this word problem. We're going to have to apply the correct transformations by starting with f of x equals log base 7 of x. Alright, so the first thing we notice is that we have a translation right 2 units, so we are going to have a transformation that occurs inside the parentheses, which is known as the argument of the logarithm. The next thing I'm going to notice is that I have a horizontal stretch, and when I have a horizontal stretch, that also occurs inside the argument of the logarithm. So if it's a scale factor of 2, but it's a stretch, that's going to make it 1/2, and then I will apply x minus 2 as my right transformation. If I have a reflection across the x-axis, that means it's reflecting from upwards to downwards. So that means I'll be changing the y values, which will occur outside, and that is the transformed function after applying these transformations to it. Question number 5, we'll be graphing. You'll notice that from previous versions of this, the asymptotes are already in place. You'll draw those asymptotes based on the translation left or right of each of these functions. So you'll notice before the vertical asymptote was at 0, now it's located at positive 3. That's because this entire graph shifted over 3. You'll also notice that the critical value usually occurs at 1, 1. In this case, it's going to be for 2 because of the movement up. You'll notice the critical value that usually occurs at 1, 0 now is going to be over at 4, 1 because of the translation up 1 unit. And then you can estimate the rest of your graph by simply drawing it here. So the two critical values you're looking for on the logarithm function are your asymptote and then that value which is at normally at 1, 0. The domain of this is going to be greater than the asymptote, which is 3. Remember, it cannot equal the asymptote, so that's why it's going to be this. If you wanted to write it in interval notation, it is simply 3 to infinity with parentheses. Because this never goes flat, that means your range is all real numbers, negative infinity through positive infinity. Question number 6. You'll see that the asymptote is already drawn. Now instead of being at 3, 0, it's going to be 3, 3 because I've got a vertical translation of 3. The other thing I've got to notice is that the base of this logarithm is 1/3. Since the base of the logarithm is 1/3, that means that using properties of exponents, this is going to be decay. If it's decay, you do not get this curving up line. Instead, you get an inverted line, which looks like this. So you have to be very mindful of the base to determine the orientation of the logarithmic function. You'll notice that additionally you have a stretch by a factor of 2. So that means my domain is going to be larger than the asymptote, and I wrote this one incorrectly. For those of you paying attention, you probably already caught it, and we're getting ready to tell me all about it in class tomorrow. And the range is all real numbers. Of course, you could write it in interval notation if you wish. Question number 7, you'll notice that there is no asymptote pre-drawn. That's because there is no shift left and right. The way that I know that is that there are no parentheses binding the x and the -5 together. So you'll have to make special note of that in the future. So that means instead of being at 0, 1, 0, we're going to be at 1, -5. And I have a compression of 1/5, so it's going to be rather flat as it rises. Again, greater than the asymptote, and still all real numbers. So please be mindful of the base of logarithms. That drastically changes the shape of the logarithm, whether it's a growth or decay model, going back to your exponents. And please pay particular attention to your parentheses to ensure that you're using the correct transformations. This is up and down, not left and right.